Okay, hello everyone. We're Coronavirus 2 and today we're going to talk about price elasticity of demand. We'll cover these questions. First, definition of elasticity and its application. Second, what is the price elasticity of demand and how is it related to the demand curve, revenue, and expenditure? Okay, I'm Nguyễn Thúy and firstly we'll take a look at very common scenario. Pretend that you're selling a normal good X with a price of $100 per piece, but during the COVID-19 outbreaks right now, you consider to raise your price up to $150 per piece, including your opportunity cost. But according to law of demand, you won't be able to sell as many as before if you raise your price. So finally, will your total revenue increase or it's going to be declined? We have to take a more detailed look in this topic. Okay, elasticity is a measure of how much consumers and suppliers respond to changes in market conditions. In other words, this one is a numerical measure of the responsiveness of quantity demanded or quantity supplied to one of its determinants. Specifically, here we got a question in our scenario that how much the demand for your good X will fall if you raise the price. Okay, now we move on to price elasticity of demand. This one measures how much quantity demanded or purchased of a good responds to the changes in the price of that good. As you can see right here, we got 5 different types of price elasticity of demand corresponding to the results of this division. Okay, and I got an example here for you. As you can see, the price rises by 10% while the quantity demanded falls by 15%. Using this mathematical operation, you got that price elasticity of demand equals 1.5. So this one belongs to a relatively elastic situation.
Hello teacher, my name is Trần Bạch. As I mentioned before, this is how you calculate the price elasticity of demand. And now I will show you how to calculate the percentage change in quantity demanded and price. As usual, we use standard formula to compute the percentage change. We take end value minus start value and divide it by start value and times 100%. This is an example of demand for good X. As you can see at the point A, with the price $200, you will have the quantity is 12. At the point B, with the price $250, you will have the quantity is 8. Going from A to B, the percentage change in price is 25%. But this formula has a problem. That is, it will show you different answers based on where you start. For example, if you're going from A to B, using the formula, you can find the change in price is 1.3, and going from B to A, you can find the answer is 2.5. These both answers are different. So it's okay if you calculate the change between new and old value, but for elasticity, it's related to both price and quality change, so it may have different results if you use standard method. So I recommend you to use the midpoint formula. You take the end value minus start value, then divide it by midpoint, then times 100%. The midpoint is the number halfway between the start and end values, the average of those values, which means you take the sum of 2 values, then divided by 2, you will have the midpoint value. It doesn't matter which value you use as the start and which is the end. You can get the same answer either way, so you can avoid taking mistake. Using the previous example, you can count the percentage change in price equals 22.2%, and the percentage change in quality equals 40%. The price elasticity of demand, you take 40 divided by 22.2, then you can have final answer is 1.8. That is how you calculate the percentage change in quality demanded and price. Thank you.
Hi. Well, to the next speech of us will be the price elasticities. My name is Phạm, Đặng, Quang, Vinh. So in the price elasticity for these questions, let's follow me to answer the question, which factor would have effects on the price elasticity? For instance, the price of both of these products rise by 20%, which product will show a downward trend in quality of consumptions. We will go to the first example. The price elasticity is higher when close substitutes are available. For light meal like the breakfast, if there has been an increase in the cost, in the cereal costs. Well, you know, the cereal is one of the morning selections of breakfast, but the rise in the price of that product results in the consequence that people will choose another product instead, such as the sandwiches, pancakes, or sweetened light meals. Since you know the breakfast is a variety of things to eat, people will change the foods for it, because cereal all still have another close substitutes. How about sunscreen? Um, the sunscreen seems to be in another case. The consumptions of product may not change in demand because there are no close substitutes for it. Next, price elasticity is higher for narrowly defined goods than broadly defined ones. The second one will be about the specific things with the own limitations, and the things have lots of quantities. Even though that is the projector, even though the projector is narrowly, but it is substitute product, so that can has a various kind of product. In contrast, the classroom will not have the substitutes of broadly defined good. Well, when it comes to the third example, price elasticity is higher for luxury than for necessity. The insulin will be one of the essential things to the diabetic. Since if fast supply, well, honestly, there will be no decrease in demand when the cost per dose rise. The pros is different from what I have just said before because it's take money, but it's not actually important for most of people. To the final one, price elasticity is higher in the long run than the short run. When we have less condition or solve the problem at the short term, we would rather use the gasoline in the short terms, but for the convenient or easier to control the using gasoline, people will prefer such a small car. And in conclusion, I will mention about the four main points that affect the price elasticity. Thank you.
Okay, hello, my name is Thảo. Now I want to tell you about the total revenue and elasticity. About the total revenue, I will give an example about this, but first I think that we should know about the definition. So the total revenue is pretty much from the goods and services, and it is equal to the price of goods times to the quantity sold. And you got to know that when price changes, then the total revenue also changes. But a rise in price doesn't always increase the total revenue. So we're gonna go through it. Let's look at this table. First, about the elastic demand. When the price go down, the total revenue will increase. For example, this product has a really good substitute for it now, but if we cut a price of our product and people will buy the cheaper item, or our price cut increases the quantity sold, and that increases the revenue. For the second, that's inelastic demand. When the price go down, the total revenue will decrease too. The idea here that we only have some buyers that will buy this certain good, so we have some buyer and their demand is always the same. So their demand is not gonna go higher or lower based on the trend in price. So you want and you can't increase the number of buyers or just selling the same buyers at cheaper price, and it will lead to the loss in the total revenue. I will give you an example that when we sell insulin cheaper, but we are only sell to the same crowd of diabetics, so they only buy the amount that they need, and so we just selling it to these diabetic at a cheaper price. That will make us lose the money. About the unit elastic demand, when the price decrease, so the total revenue does not change. Next, we're gonna talk about the total revenue test. So this is the definition, but I think that it is not exactly as important as what we have next. So you can read it here, and I will move to the next slide. This is the main idea of total revenue. There are three main ideas that if a price cut increase the total revenue, demand is elastic. The second, that if a price cut decreases total revenue, demand is inelastic. And the last is if a price cut leaves total revenue unchanged, demand is unit elastic. You can read all the things about the main idea here. I will give you an example for this. As you see on the screen, there are two graphs. The first graph shows the relationship between the elasticity of demand and total revenue. So we're gonna have our price fall from $25 to $12.5, and this will cause the quantity demand increase from 0 to 25 hot dogs. And with this effect, we found that on the previous slide. So our demand is elastic and the total revenue increase. So we're gonna we're gonna go to have a look at this second graph. This is our revenue graph. With the quantity demand from 0 to 25, the demand is elastic and total revenue increase. And this is so in this graph with this arrow tracing the curve going this way. And this arrow represents an elastic demand, and it represents that when we cut the price, the total revenue would increase. So let's go on to the unit elastic. It's over here, and let's just take our information at $12.5. The demand is unit and the total revenue does not change. It means that the total revenue stop increase, so the unit is also here on the first graph, and on the second graph is here at the top of the graph, and it's also the maximum total revenue. We can easily find the total revenue that's by take 25 times to 12.5, and we get 312.5, and that is the maximum total revenue. It's also the unit elastic. And now for the last part, we'll focus on the right side of the second graph. Let's say that the price fell from the 12.5 to 0, and in this case our quantity demand increases from 25 to 50, and this demand is inelastic and the total revenue decrease. So this part represent on as this lower part of life of straight line on the first graph, and on the second graph this is an arrow from the maximum total revenue go down. This is all I want to talk about total revenue and elastic. Next is about your expenditure and your elastic, because this is just an extra part, so I think that we will go faster and get started. You can read it on the screen. That's all my part.
So the next thing we're gonna talk about is the application in real life. So after all the theories we have learned today, what is the application in the real life? Does the face mask interdiction increase or decrease face mask inflation during the breakout of COVID-19 pandemic? And one of the side effects is the price of face masks is exceptionally high compared to the old price, which make it harder for people who have low income to buy it. And we're gonna examine two policies in order to reduce the price of face masks and therefore to examine the effects of the inflation. So for simplicity, let's all assume the total money I spend for face masks are equals to the total money value for face mask inflation. And because the demand for face masks is elastic due to the need during the breakout, elastic means when the price changes, the demand for a good relatively stay the same. So policy 1, interdiction. Interdiction reduces the supply of face masks, and since the demand for face masks is elastic, the decrease in quantity is much smaller than the increase in price. As you can see the graph on the right side, I have demonstrated for you. So the result is an increase in total spending on mask and face mask inflation rate, which means the inflation rate isn't decreased. So this is the price and the quantity. I have calculated the percentage change by using the midpoint method, and the price elasticity of demand is 0.8%, which is smaller than 1. And this is why the price elasticity of demand is elastic. And the total revenue is increased, and therefore the inflation rate also increased. About the second policies, government announcement. So government announcement to those who sell face masks with an incredible high price will be withdraw the license. And by using this method, it has reduced inflation prospectively, and the result is a decrease in total spending on masks and inflation rate. This is the price and the quantity after decreasement, and I have calculated the percentage changes and using the midpoint, and this is the price elasticity of demand is 0.9%, which is smaller than 1, which means the price elasticity of demand is still elastic. But about the inflation rate, as you can see in the graph, it have decreased in much smaller, and the total revenue has decreased, and therefore the inflation rate also decreased, which means the policy 2 is actually working compared to the policy 1. And therefore our presentation. Thank you for listening. Okay, stop recording me.